Hi everybody, welcome back. A couple things for you for today's lesson. One, just keep remembering to keep checking Schoology and get stuff done for your teacher. And two, a reminder that your teacher has set a deadline for missing or late work from weeks 1 through 6 coming up this weekend. For me, it's Sunday at January 31st at 11:59 p.m. For Mrs. Larson or Mrs. Lee, I think it's the same, but it might be within a day or so different. Please make sure you check with your teacher about that. So today our lesson is to describe why we balance a chemical equation. So in Schoology, you will find a set of notes for today. Schoology Chemistry Week 7, Lesson 2, and then there you'll find something called Intro to Balancing Equation Notes. So yesterday in class, we wrote out some equations. We practiced writing some equations together, and these were 3 of the equations that we wrote. And the question I have is, what's wrong with all of them? You may have noticed this yesterday, especially if you knew a little something about chemical equations beforehand. Let's give us a clue. Count the atoms. Okay, so let's go ahead and let's just look in the first equation up here, and let's look at the number of hydrogen and oxygen atoms we have before and the hydrogen and oxygen atoms we have after. So before, I have 2 hydrogen atoms and 2 oxygen atoms. Okay. After, I have 2 hydrogen atoms, 1 oxygen atom, but 2 more over here, so 3 oxygen atoms altogether. So the question someone might have is, when this reaction happened, where did this extra oxygen come from? We had 2 and now we have 3. Same thing for our next equation, right? Beforehand, we have 1 magnesium and 2 oxygens. Afterwards, we have 1 magnesium and 1 oxygen. What happened to that extra oxygen? Did it go poof into air? Okay. Same thing, we'll see the same kind of thing in the last one down here. For example, before the reaction, I had 2 potassium. After, I only had 1. Okay. Before, I had 3 nitrate groups. Afterwards, I only had 1. So someone might ask themselves, where are all these atoms coming from and where are they going to? Well, this is a problem when we don't have the same number of atoms on both sides. It's a problem of balance. Why is it a problem? Well, it's a problem because it violates something called the law of conservation of matter. Okay, the law of conservation of matter says that matter cannot be created or destroyed in a chemical change, but the particles can combine, separate, or rearrange. So in other words, we can't take particles and make them go away or make them appear out of nowhere, but we can take them apart and reassemble the pieces in new ways when we have a chemical change. All right, so how does this apply to equations? Well, we know that matter is made of particles, and particles are made of atoms. And in the equations we've written so far, it looks like matter is being created or destroyed because extra atoms appear and others are seen to disappear as we go from one side of the reaction to the other. We say that kind of equation is not balanced because it looks like atoms are being created or destroyed. So how do we solve this problem? Well, in order to obey the law of conservation, we have to make sure that we have the same number of each kind of atom on both sides of the chemical equation. So by sides, we mean reactants and products. So if I have 2 hydrogens in my reactants, I need to have 2 hydrogens in my product. If I have 6 oxygens in my reactant side, I have to have 6 oxygen atoms on my product side. All right, so if we look back at our demo equation from yesterday, this was this H2O2 equation. We can instantly see that this is wrong because it looks like we've got an extra oxygen appearing on the right-hand side. So how do we fix it in our equation? Well, we add coefficients. What do I mean coefficients? We put numbers out in front of each of our substances so that the law of conservation is obeyed. What that does is it changes everything that we have after that and multiplies it by the number in the coefficient. So that's a balanced equation. Let me show you how that worked out for us. Okay, so now before the reaction, how many hydrogens do I have? Well, there's 2 in the equation, or in the formula, times the 2 out in front. So that gives me 4 hydrogen. Likewise, there are 2 oxygens in the formula times the 2 out in front. So that means that there are 4 oxygens beforehand. Afterward, we have 2 hydrogens in the formula times the 2 out in front. So that's 4 hydrogen. Also in that formula, we have 1 oxygen times the 2 out in front. So that's 2 oxygens. Plus, we still have 2 more oxygens over here. So that gives me 4 oxygens. So 4 hydrogens before, 4 hydrogens after. 4 oxygens before, 4 oxygens after. So our next step as we move through, now that we kind of understand why we have to balance equations, is to learn how to balance equations. This is what we're going to focus on over the next few days. But I'm just going to show you a couple examples, and then we have another video that will also show you some examples that you'll hopefully start to pick up on how this all works. So I just worked these problems left to right. So let's do this first one, which was one of our sample problems from yesterday. Magnesium plus oxygen goes to magnesium oxide. And I'm going to go ahead and I'm just going to start. So I'm going to start by counting on one side and matching for the other side. So how many magnesiums beforehand? I have 1. How many afterwards? I have 1. How many oxygens before? 2. How many oxygens after? 1. All right, so I need more oxygens over here. And the only way I can do that is to put a number out in front. What number can I put out in front to give me 2 oxygens? Well, 1 times 2 would give me 2 oxygens. So I've gone through this left to right once, but now I'm going to go back and I'm going to double check. So now I have 1 magnesium before. Oh, now I have 2 magnesiums afterward. So I'm going to go ahead and I'm going to put a 2 out in front of that. So now I have 2 magnesiums before, 2 magnesiums after. I have 2 oxygen before, and I have 2 oxygen after. So this one is now balanced. Here's another one. Okay. Copper plus silver nitrate goes to copper nitrate plus silver. Okay, and this one, it's a little bit useful for us to recognize that we've got the same group on both sides, the NO3. We can keep that together or not keep it together, but we typically find it easier to keep it together. So I'm just going to go 1 copper before, 1 copper after. 1 silver before, 1 silver after. Okay, good. Nitrates or nitrogens. Well, I have 1 nitrogen before, and I have 1 afterwards times that number out back. So that actually means I've got 2 of them there. Or if I want to do the whole thing, I've got 1 group of NO3 here, and on this side I have 2 groups of NO3. So I'm going to go ahead and I'm going to put a number out on front over here to make sure I have 2 NO3s on both sides. Okay. You'll notice that that just changed the number of silvers that I have. So I'm going to put a 2 over here to make sure I have 2 silvers on both sides. 1 copper, 1 copper. 2 silvers, 2 silvers, 2 nitrates, 2 nitrates. Again, you'll get a lot more practice with this in the coming days. So if that didn't go very well for you, if you didn't follow that very well, we've got lots more practice coming. So here's the rest of your work for today. 1, going to watch a short video called Help with Balancing, which will go sort of through that balancing process that I just did, just a little bit more step by step. And then take a very short 5-question quiz on interbalancing equations that's in Schoology. Have a great day.